Hi everyone, my name is Shubhanshu Mishra. I will be presenting this work done at Twitter with Arya Hakiki on improving multilingual language model pre-training for social media text by translation pair prediction. There is a large population all over the world which doesn't use English language to communicate. Even on Wikipedia, there is a significant amount of content which is in non-English language. Additionally, languages are orthographically different, that is, they use different scripts for the written word, which makes machine learning model transfer across these languages to be challenging. In a previous work on multilingual NER, we found that the model performance while multilingual training was good for languages which used a similar script as English. However, the model performance was quite low for languages which had a different script like Arabic and Hindi. This motivated us to study model transfer more narrowly from English language to orthographically different languages. As a follow-up, we decided to look at Multilingual BERT, which is a pre-trained model on multilingual corpora. It has shown promising results on multiple languages in terms of positive task transfer. We start by asking if embeddings of the same sentence are closer to the respective translations. We find that this is not the case. Instead, embeddings often cluster based on language identities. Our hypothesis is that we align these embeddings so that the translation embeddings are closer to each other. This will allow for zero-shot transfer, as the model will have similar representation for all translations of a sentence in various languages. We start with the following observations. Misalignment of language models implies lower zero-shot transfer capabilities, significant accuracy drop for orthographically different languages, and availability of translation pairs of varied quality in aligned language models. Our setup is simple. We start with an existing multilingual encoder, for example mbert, and then we add the translation pair prediction task and train on this task using given language pair data or a collection of language pair data. The resulting model can then be fine-tuned on a downstream task. For experiments, we consider transfer from English to the following orthographically different languages: Arabic, Japanese, and Hindi. We source translation pairs for these languages from sources which vary in translation quality and scale. Tatoeva resource consists of human-written translations. Wikimetrics consists of translation pairs extracted from Wikipedia using nearest neighbor search, using a translation model's embedding. And finally, we introduce a new resource for generating new translation pairs based on Wikidata. Our Wikidata translation pairs can be easily generated by taking the Wikidata labels and descriptions in various languages and concatenating them to get a language-specific sentence. We consider the following experiments using mbert fine-tuning as a baseline. We then add TPP using a single data source, a pair of data sources, and all the language pairs. After adding the TPP task, we evaluate the models for zero-shot transfer from English to a different language, with the hypothesis that the alignment should improve this transfer compared to an unaligned model. It is important to note that this assumption will not always be valid, as some tasks don't have a one-to-one mapping when going from one language to another. For example, sentiment and abusive words in different languages might not have a one-to-one mapping. Since our goal is to improve performance of social media datasets, we consider NER and sentiment datasets based on social media data. We also add a non-social media corpus from universal dependencies part of speech tagging to assess performance in a standard domain. Experiments reveal that aligning with models via TPP improves zero-shot transfer significantly across tasks and languages. The biggest improvement is for NER, which was our original motivation for considering alignment. Next, we look into performance improvement for each experiment in detail. TPP via every resource shows improved performance on NER tasks, with biggest performance using a pair of data sources. The biggest performance improvement is also for Japanese. Performance improvement on sentiment task is not as good as NER. This is probably because of the semantic nature of the sentiment task, whereas NER is more syntactic. There is also a drop in performance when using Wikidata source, likely because of the lack of any sentiment-specific translations. Finally, we compare on a non-social media corpus using part-of-speech datasets from universal dependencies. Again, the improvements are consistent with the previous experiments, though they're not as big as we get in the NER task. We also consider reasons for the varying improvements based on the sources. We reason that this has to do with the quality of translation pairs as well as the scale of the translation pairs. We conclude that TPP is a simple objective which can be added to any existing encoder to improve zero-shot transfer, We highlight that practitioners should not expect multilingual embeddings trained on combined language data to share information across orthographically different languages. We find evidence for varying impact of embedding alignment based on the nature of the task. Our results are important as most social media datasets are in English and there is very less PyText corpus available in social media domain. We invite the community to utilize our zero-shot transfer downstream setup as a benchmark to evaluate multilingual performance on social media text. More details of a dataset and implementation can be found in our open source code repository. Thank you, and we are happy to take questions here or on Twitter or on our GitHub repository's discussion section. Thank you.